Hello class, let's begin with the solution of the midterm for type B, the midterm type B. I'm gonna be solving pretty much every problem except a couple of problems at the end, which are extremely simple and everybody got right, which is this one number 4 and this one number 3. You should have got this right, guys. 3 and 4 from section B. These were extremely simple stuff. Okay, let's start already. So problem number 1, we have one four-sided red die and one six-sided blue die. And they are rolled, and they want me to find the probability of the following events: A, B, C, D, E, F, and G. So let's begin. In this case, what is my sample space? What is my sample space? If I assume that the red die is the first one, like I'm gonna write my outcomes in this way: red die, blue die. I want to write the outcomes in this way. It could have been the other way around, blue and red. They never tell me which one is the first die and which one is the second, so it makes no difference. Red and blue. So the outcomes should look like this: 1, 1, etc. until 1, 6, because the blue die is the normal one with 6 sides, and then 2, 1, etc. until 2, 6, 3, 1, etc. until 3, 6, and 4, 1, etc. until 4, 6. This is it. This is the whole sample space with this many outcomes. How many do I have? Total of 24 individual outcomes. 4 rows with 6 columns. 4 times 6, 24. Okay, and I began solving each of these questions, right? The probability of A, what is the event A? Both dice are 2. So how do we reason this out? Basically, remember that the classic definition or formula for probability, which is the number of favorable events over the number of favorable outcomes over the number of possible outcomes. Okay, this is the most basic definition of probability, and that's what I'm about to do. This event has only one favorable outcome, namely the outcome 2, 2. So it's just one favorable over 24 possible ones. That's the solution. B. What is the probability of the event B, which is they are unequal? Both dice are unequal. Well, you can get this by basically by writing this, right? Remember, this is one of the other standard formulas that we have. The probability of an event is equal to 1 minus the probability of its complement. And it's easier to get the complement of this one because the complement of B is B prime. They are equal. They are equal. Both dice are equal, which has only 4 favorable outcomes, which is 1, 1, 2, 2, 3, 3, and 4, 4. So the probability of B prime, which I'm going to write here, that's 4 over 24. And therefore, since I already have this, 1 minus 4 over 24, that's going to give me 20 over 24. And that's the solution. We continue. C. what is the probability of the event C? One die is a 2 and the other is a 3. Favorable outcomes are this one and this one. These are the only two favorable outcomes to this event, in which one die is a 2 and the other is a 3, as you can see. So two favorable ones over 24 possible ones, that's it. Letter D. Find the probability of event D. Both are odd. Both are odd. Okay, so in that case, we have the following. This probability can be obtained in this way. That's going to be the same as the probability of the red being odd and the blue being odd. Okay, so it's the probability of an intersection. Remember that the and means intersection of this event and this other event. Now realize that the probability of the red die being odd and the probability of the blue die being odd, they are complete. I mean, the events are completely independent. Okay, whether the red is odd makes or has no impact on whether the blue is odd or not. Therefore, these two events are independent, and therefore I can apply the formula. This will be the same as the multiplication of this probability and this other probability. The probability of red being odd times the probability of the blue being odd. And since I know each one of these, because it's very simple, right? What is the probability of red being odd? It's 1/2. And the probability of blue being odd is also 1/2. 1/2 times 1/2, 1/4. And that solves letter D. Letter E, the sum of them is 11. The sum of them is 11. Basically, I have to investigate my sample space and spot how many outcomes of this make up for a sum of 11, which will be only neither, right? This is 0, because the highest sum that we can get out of these outcomes is this one, which is 10. 4 plus 6 is 10, and this is the last outcome in order. So the probability of this event is just 0. Okay. F, what is the probability of the blue die being a 1 given that the red is a 3? Okay, let's write that down. The probability of the blue being 1 given that the red is 3. Well, this is a conditional probability, but you have to understand that whether the red die is a 3 or not makes no difference. Okay, it has no impact on the blue being 1. In other words, these two events are independent. And if for independent events, the conditional probability basically just goes down to the probability of the first event. It's just simply the probability of blue being 1, regardless of whether you know that the red die is a 3. That makes no difference. So the probability of the blue being 1 is 1/6, right? Because the blue is the one that has 6 sides. And finally, the probability of G, the sum of them is 5, given that at least one of them is a 2. Okay, this sounds a little more complicated. You should realize that this is the first event, this is the condition, and this is the conditional. This is the given, the bar, the vertical bar. The probability of this given this. Okay, I may as well erase. I'm gonna continue here because I have no more space. I'm gonna continue with yellow. Okay, so let's reduce the sample space. Remember that when something like this occurs, like when you know that something has happened, then what that has as a consequence is that the sample space is reduced. This is the original sample space, but now that you know that at least one of them is a 2, then this sample space is reduced or collapsed or shortened or whichever way you want to look at it. So this is the new sample space. I'm going to call it Sn for sample space new. And now, since I know that one of them is a 2, I must have something like this. The red, let's suppose that the red die is a 2, and therefore all of these outcomes okay, all of these outcomes are compliant with this conditional. And also now let's suppose that the blue, which is the second number, the blue is a 2. So I should have this 1, 2. And then don't include again the 2, 2 because I have already counted that possibility here. So bypass this one and jump to this one, 3, 2. And then 4, 2. And I stop right here because remember that the red die, which is the first number, cannot be greater than 4. And that's it. This is my whole sample. This is my whole new sample space, which consists of 1, 2, 3, 4, 5, 6, 7, 8, 9. 9 possible outcomes. Okay, and that's it. That's it. You no longer care about this sample space, but this one. And just count how many of these outcomes how many of these outcomes satisfy this first event, that the sum of them is 5. It's gonna be this one and this one. Okay, so conclusion: the probability that the sum of them is 5, 2 favorable outcomes out of 11. Therefore, the probability of G is 2 over 9. I think I said 11. I don't know. I can't remember. I meant 9. 1, 2, 3, 4, 5, 6, 7, 8, 9. Yes, 9 possible outcomes. And this is the last answer for this problem. This finishes this problem. I'm gonna be making or taking pauses in between problems, and then I will come back with you. Okay, next problem, problem number 2. And it states the following: for two events A and B, we have that, but the probability of B is 0.3. Let's write that down. The probability of A given B is 0.2, and the probability of A prime intersection B prime is equal to 0.1. And that's all they give me. And then they ask me a series of questions. Okay, this is a purely how can I say this? Purely analytical problem, in the sense that I mean there is no content in the events. I mean this is a purely symbolic problem. I don't know what to call this type of problem. We don't know what the events are. That's what I'm trying to say. We don't know what the events are. We have no context, no nothing. And okay, let's begin. Question A. Find the probability of A and B. Once again, you cannot do this, guys. You cannot write this for your life, okay? You cannot write this because you don't know whether A and B are independent from the context of the problem. You cannot do this, at least not now. So you must employ some other reasoning process. What about using this conditional probability? I mean, I know that the definition of conditional probability, or the formula, whatever you want to call it, is equal to the probability of A and B over the probability of B. Okay, and then I can see by writing it down that this appears in here. So maybe this will help me solve the problem. And in fact it will, because I have this quantity and I have this quantity. So it's pretty clear that it's gonna work. So this is 0.2 equals this, and we can readily see that this is gonna be 0.06. That's it. That solves question A. Question B. Find the probability of the event A. Okay. Okay, and this is where a lot of you are still making that mistake. You think in this way. You think I have this probability because I have already calculated it, and then I can write this, and since I have this, and since I have this, therefore I can get this. Wrong. You can only use this formula for independent events, and at this moment, nothing in the context of the problem and no deduction by you has prompted you to say this or to establish that this is true. Therefore, you cannot use it. You cannot use this law or this formula. Okay, so what can you do? Something else. Something else. There's no way around it. Let's try to get it via the Venn diagram. This circle represents event A, this one event B. This little intersection here obviously represents the intersection of both of them, and the area that is outside right here represents when neither of the events happen, neither A nor B. Okay, let's reason. Let's try to reason out of this, and let's see if we can get the probability of A by analyzing the Venn diagram and all the areas that we have already. Remember, the areas the areas of these shapes. Okay, for example, if you pay attention to this area, or this enclosed area, the area of this is the probability of A intersection B, which you already have. Okay, this area is 0.06, this white area. Okay, and that's how you can reason by using the Venn diagram in terms of visual areas, uh, and intersections, and try to reason something out. Just listen how I'm gonna do this problem. So I know already this white part, which is 0.06. Now if only I could get this other bit, this other enclosed area or separate area, all of this that I'm painting yellow. If I could get this area, then I'm done, because the sum of this yellow area plus this white area, which I do have, is actually the probability of A. So if I could get the yellow area, I'm done. So let's see if I can do that. Let's see if I can get the yellow area. What else do I have? I have this. Look, take a look at this. Take a look at this. I have the probability of A prime given B prime, and I have also the probability of B, which is all of this. Not just this, but the area of all of this. So let's see what I can do. How can I represent, how can I represent um, this, this area pictorially, visually? Like if I wanted to highlight the area that corresponds to this event, what area should I paint? A prime intersection B prime. What is A prime? Is everything that happens outside A. I'm not gonna paint it because I don't want to make a whole mess. A prime is everything that happens outside A. What is B prime? Everything that happens outside B. So if you wanna talk about the intersection of those things, then you must realize that that intersection or this event is equal visually to all of this. I'm just gonna paint it. It's all of this. It's everything that happens outside A and outside B. It's all of that blue area. This event, guys, A prime intersection B prime, is the blue area. Try to understand why. Try to understand, and don't stop until you completely understand why this blue area symbolizes this event. Okay. Okay. Now, what else can I do? So I have this blue area, which is 0.1. So the blue area is 0.1. What else do I have? I have this red area. What is this red area? It's the following. The red area is equal to the probability of B, the full probability of B, which is 0.3, minus the probability of the intersection, which is this, right? And that's going to be equal to 0.024. That's the red area, 0.024. And look at these guys, you already have everything. You have the blue area, you have the white area, you have the red area, and the only thing that you're missing is the yellow area. And if you notice, the whole rectangle is already painted. Okay, I took it took I took a lot of time in order to explain to you all of these details about the blue area, red area, and how much it is, etc. I repeat, guys, we know the blue area, we know the red area, we know the white area. The only area that is missing here that we don't know at this moment is the yellow area. Okay, and now I can calculate this yellow area. Why? Because the sum of all of them, the sum of all of these areas should be equal to 1 because they fill the whole rectangle. I'm going to make that explicit over here. So the yellow area plus the white area plus the red area plus the blue area should be equal to 1. And that's it. I know white, which is 0.06. Let me put that 0.06. I know red, which is 0.024. I know blue, which is 0.1, and that must be equal to 1. That's it. I can calculate therefore the yellow area. I'm gonna use a calculator because I wanna make fast. I wanna be faster, but you were not supposed to use it. I mean, you can do that manually. It's quite simple. So this is 0.184. That's the yellow area. That's the yellow area, and therefore I can calculate the probability of A. Is this the probability of A? No. No, 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 no. Don't get confused. This is just the yellow area. And the probability of A is the sum of the yellow one plus the white one. So here it goes. The probability of A is the yellow area plus the white area in order to make the full circle, and therefore I'm gonna get 0.244. I'm gonna check this result in a moment because I want to see if it checks with the previous answers that I gave you. I suppose I hope I'm not making any dumb mistake in the process, because otherwise I'm gonna have to correct it. Everything seems the error is right here. Yeah, I knew it. I knew I was doing something very dumb. Okay, this is 0.24. Sorry guys. 0.24. Then this is 0.24. Then y equals 0.6, and 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 that's it. Okay, this is the yellow area, and therefore the probability of the event A, which is yellow plus white, is gonna be 0.66. Okay, I'm gonna check again, but as far as I can tell, everything is correct now. So that's the probability of A. Um, does it take a lot of time? Not really. I mean, it took me a lot of time to get down uh, to this answer because I was explaining to you with enormous detail how this works. If you don't have to explain anything and just do it, solving this particular exercise should take you about, I don't know, 4 minutes, maybe less. So this is the probability of A, which is the question B. Okay, let's continue with letter C, the probability of A union B. Let me write down the general formula when we have or, okay, union. This is the one, and this one always works. Do I have the probability of A? Yes. Do I have the probability of B? Yes. Do I have the probability of intersection? Yes. That's it. There's nothing else to do, guys. I mean, actually, if you just put the values here and don't even make any arithmetic, like if you just gave me the following stuff, then that's correct. That's correct. I don't care about the arithmetic, but just for completion, this should be 0.9. Am I right? Yes, 0.9. Then probability of D, well, the probability of A prime given B prime. How can I get this? Well, once again, I make use of the formula for conditional probability, which is the following. The probability of the intersection of both events over the probability of the event that is a conditional. So it's just this division. Do I have this value? Yes, it's 0.1. Do I have the probability of B prime? Yes, because I know the probability of B, so it's pretty simple, right? It's going to be 0.7, and that's it. That's it. And finally, E, determine whether A and B are independent. No, I'm gonna do that in blue over here. No, because when you calculate this, which is this one, and you calculate separately the multiplication of the probabilities of A and B, they're not equal. This is not equal to this, and therefore, conclusion, they're not independent. In here, you made a classic mistake in here. A lot of you, a lot of you who used at the beginning over here in this part of the problem, when you use this right at the beginning of the problem without any good reason for using it, then clearly, if you use this, then obviously you will find that in the question A, they're going to be independent because you already assumed it at the beginning, right? So it's obvious that E will be answered in the positive. Like, yeah, they are independent because you already assumed it without good cause at the beginning of the problem. So this is what we call a circular argument. It's kind of like saying uh, uh, student student one is good because student one is good. You see, it's a circular argument. It doesn't. I'm not proving anything. You see, so that's the problem. A lot of time on the explanation because I want you to take a look at the nuts and bolts of these problems. Okay, now problem number 3. Yes, in this one there were two possibilities. Like somebody told me at the time of the exam, you were right. It's in that sense it is ambiguous. Although I mean you can actually get both possibilities, and that's it. At least one. At least one. So number 3, consider the following data set of positive integers. They are positive integers, all of them. Okay. So let me write down 2, 5, 7, 3, 1, 9, 8, A and B, where we know that A equals 3B, and I tell you that this data set has two modes. So I know this, and I know that there are two modes. Two modes. And that's it. That's the whole context. I give you this data set. 1, 2, 3, 4, 5, 6, 7, 8, 9. The number of elements is 9. I know that A is 3 times B, and I know that this dataset has two modes. Okay, what can I conclude out of inspecting this dataset and these two pieces of information? I must realize that neither of these numbers that I know, 2, 5, 7, 3, 1, 9, and 8, neither of these repeat. Neither of these repeat. So if I know that there are two modes, what that means is that A and B must be, by necessity, one of these 7 numbers. Like for example, A could be 1 and B could be 3. Okay, I'm saying could. I'm not doing any arithmetic yet, because at least in that way, then I'm gonna have as most 1 and also 3, right? Because they would be repeating themselves twice. Okay, so that's my point. At least I know that A and B must be one of these 7 numbers and no other possibility. No other possibility. But then I have another restriction, this one, that A should be 3 times B. Okay, so when you play with these two uh, data facts, or yeah, with these two facts, you come to the conclusion that A could be 3 and B could be 1. Okay, because in this way, this complies with this equation, right? Just substitute these two numbers in here, and it's gonna is going to be satisfied. But there's also another possibility, the one that I didn't see at the time of making the exam, which is this. A also could be 9 and B could be 3. Okay? These two, this other possibility also complies with this equation, as you can see. And both of these possibilities also comply with this one. If I decide for this, then my modes are going to be 1 and 3, and the frequency of each mode will be 2. And the same for this one. If I decide on this, then my modes would be 9 and 3, and also the frequency of each mode is going to be 2. So, how should I answer letter A? Calculate the value of A and B. I have two possibilities. A equals 3 and B equals 1, or A equals 9 and B equals 3. That's it. Both of these are perfectly good. And find the mean and the median of this data set. Well, I'm not gonna do this. I mean, this is something I'm just not gonna do. This is extremely simple, guys. The mean, which is the average, and then the median. First, you first calculate both mean and median with this possibility, and then with this other one, and that's it. But I mean, this is extremely simple. I don't think you want to see me doing that stuff in front of you. So I'm gonna consider that all of you got this one right. And that's it, right? Yes, that's the end of problem number 3. And problem number 4. This is once again extremely simple. You should have gotten this one right, guys. You have this data set 1, 5, 1, 1, 2, 6, 7, 9, 3, 3, 1. How many data values do we have? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So n equals 11. We have n equals 11 pieces of information. Then I'm asking you to find certain things, such as the mode, the mean, the median, the lower quartile, and the upper quartile. I'm going to do this very quickly. It's extremely simple. First, order this data set from lower to lowest to highest. So how many ones do we have? 3, 4, and then 1, 2, and then 2 threes, and then 1, 5, 6, 7, and 9. This is my this is the same data set, but now ordered or arranged from lowest to highest. And then just investigate each of these things. Mode, what is the number that repeats itself the most? And it's clearly 1. B, the mean. The mean, just add all of these numbers, guys. 1 plus 1 plus blah 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 until 9 over 11. That's it. If you wrote this, that's enough. I don't even care about the fraction itself. Like, I just care about you knowing what you're supposed to do. I'm not checking arithmetic. That's my point. If you wrote this, you should have gotten right, even if at the end you made a mistake in the arithmetic. See the median. What is the median of this data set? Of this data set? Well, it's the value that partitions the set in two equal parts, which is, I think it's number 3, right? There are 5 numbers to its left and 5 numbers to its right, so yes, the median is 3. D, the lower quartile, and E, the upper quartile, in other words, Q1 and Q3. This can be understood as the medians. Once that you have the median of the dataset, which is 3, Q1 and Q3 can be understood as the medians of the first data set in here, or the first half and the other half. So what is the median in this data set? It's clearly 1, because there is the same number of values to its left than to its right. And what is the median of this particular bit of this? It's going to be 6, because there are 2 numbers to its left and 2 numbers to its right. So, conclusion, Q1 is 1, Q3 is 6. That concludes the problem. Very simple stuff. I mean, this is 10 points basically for free. Problem. Okay, section B. Now we enter section B, which are problems a little bit more, thoughtful in a way, that require more analysis. Problem number 1. At a certain school with 50 students, 30 speak English, 20 speak French, and 10 students speak neither of these languages. And then I ask you a series of questions. That's the whole context. And I ask you a series of questions or instructions, such as, for example, A. Well, let me represent this in here. How many students speak English in this school? I'm going to represent that by E. That's 30. How many people know French? That's 20. And neither is 10. All right. Now, let's calculate how many students speak both English and French. That's the first question. How many students speak both? Well, I think we cannot. I mean, give me a moment because I'm getting confused. Okay, yeah, this question in particular, I think this one should be addressed after we do B. Let me try doing B first because I'm getting a little confused. B. Sketch a Venn diagram to represent this information. In each enclosed region, put in the number of students corresponding to this region. So this is the Venn diagram representing the whole school, and we have 50 students in all of this diagram. Let me draw a circle representing all the people that speak English. All the people in here, all the people that lay or are within the circle speak English, and all the people that are inside this other circle speak French. Okay, and the intersection means both those people that speak both English and French. These people right here, and the people outside in this outside area in the skirts. These people speak neither. Okay, very good. So let's see. I'm gonna label each of. Listen, this is very important. You must understand the difference between the whole circle and each of the parts. Each of these, let's call them separate islands or separate areas, such as this, this, and this outside. I'm gonna label those areas as X, Y, Z, and W. And you must understand that these are separate areas. Okay, and what do these things mean? What do these variables mean? They mean the number of people, in this case for X, that only speak English. X is the number of people that only speak English. Y is the number of people that speak both English and French. Z is the number of people that speak only French. And W is the number of people that speak neither, which we already have. Okay, so I already know that W is 10. What else do I know? I know that the addition of the four of them, X plus Y plus Z plus W, should be equal to 50, right? Which is all the students in the school. So I know this, I know this. What else do I know? I know that 30 people speak English. 30. And that must be x plus y. X plus y must be 30. And I know that the speaking French speaking people is 20. So that's y plus z. Y plus z must be 20. I know this, I know this, I know this, and I know this through the whole context of my problem. And this should give me the possibility to calculate each of these variables. I already have w. Now let's look for this. Look, x plus y is 30, so I know that this is 30. I know that this is 10, and therefore I can calculate z, which must be 10. So that 30 plus 10 plus 10 gives me 50. So that's my first deduction. Z must be 10. So I already have two of them, W and Z. If I have Z, I can calculate Y, which must be 10. And if I know Y, I know X, which must be then 20. And I'm done. I'm done with the calculation of each of these number of people. Okay, and after I have done this, I think I can go back to the question A and answer it in a more straightforward or a more intelligible way. So, how many students speak both English and French? By what I told you a moment ago, that should be Y, which is 10. 10 people speak both. These people, which is 10. So, first done, second question done, and then these other three. Calculate the probability that a student chosen at random speaks English but not French. I'm going to label this as event C, speaking English but not French, which is these guys in here, X, the X guys. These people speak English but not French. So basically, what is the probability of choosing one people from this area? Well, how many people are in this area? 20. How many people are in total? 50. So that's it. This should be 20 over 50. Letter D speaks either English or French. Either English or French, which is all of these people, either X, Y, or Z. All of these people speak either English or French. These people speak both, okay? But this is written in such a way that you must understand that at least one language. So it's all of these people X, Y, Z. So I'll add all of these three. Uh, X, Y, Z. That's 40 over 50. And letter E does not speak English. What are the people that do not speak English? They are either the ones that only speak French or the ones that speak neither. So it's going to be Z plus W, which is 20. 20 possible ones out of, no, 20 favorable ones out of 50. And that's it. These are your probabilities, and that solves the whole problem, I believe. Yes. Let's make a stop, and then I come back. So next, the problem number two. This is a little complicated. Well, there are some questions that could be a little complicated. So let's try this one out. So you have a person going to school every day, either by bus, bicycle, or car, and the probability of him going by bus is 0.5. I'm gonna signify that in this way. I'm gonna write BU for bus. The probability of going by bus on a given day is 0.5. The probability of going by car is 0.2, and that leaves the only conclusion that this leaves out for the probability of going by bicycle is 0.3, right? So that the sum of these three probabilities should add up to 1. And yes, that's the first thing you can do. And then they ask you the first question: find the probability that he goes to school by bicycle in Monday and Tuesday. So we have 2 days: Monday, Tuesday. And what is the probability that in both of these days, in both, he goes by bicycle? I'm writing BY instead of BI for bicycle. Okay, so how do I solve this problem? What do I do? Okay, you must realize the following: whether he goes, think about Tuesday. Think about Tuesday, and think about this question: what is the probability that he goes by bicycle on Tuesday, given that he has already gone by bicycle on Monday? These two things are independent, guys. Okay, whether he goes on Monday by bicycle doesn't affect the fact that he goes on Tuesday by bicycle. Okay, these two events are independent. So basically, this is the same as the probability of going by bicycle on Monday and and going by bicycle on Tuesday. Since these two are independent, then they should be equal to the multiplication of the probabilities, right? The probability of going by bicycle on Monday times the probability of going by bicycle on Tuesday. What is this probability? It's 0.3, because we know that the probability of him going by bicycle on any given day is 0.3, and the same for here, 0.3. So that's going to be 0.09. I'm going to call this event A. This is event A, 0.09. And then B. What is the probability that he goes to school by bicycle on Monday and by bus on Tuesday? So once again, we have Monday, Tuesday, and now we're gonna go on now here, bicycle on Monday and bus on Tuesday. Well, it's similar to the one before, only this time it's bicycle and then bus. So this is the probability of going by bicycle times the probability of going by bus, 0.3 times 0.5. That's the result. Okay, this is it. How much is this? It's 0.015, right? C. The probability that he goes to school by the same method of traveling in Monday and Tuesday. This is where it gets a little complicated. A little. How do I solve that problem? Okay, so we have Monday, Tuesday, and the question is this. Uh, the question makes reference to going by the same method of traveling, which can be, let's take this order. It can be bus. What is the probability of going bus, or uh, car, okay, or bicycle, okay? So it is the probability of this, this, and this, or this and this, or this and this. Okay, you see? Okay, now, uh, how can I resolve this? I mean, this is the probability of some event. Well, let me raise the M and T here so as to not cause confusion. The probability of this event and this event, or this event and this event, or this event and this event. This looks like a very complicated compound event. All of this is an event on its own, which is compounded with many different types of compositions in here. Okay, what you must understand is this. This and this and this are mutually exclusive. Mutually exclusive. This event going by bus and bus on Monday and Tuesday, and this event going by car and car, and this event bicycle bicycle, they are mutually exclusive. If this happens, then this doesn't happen, and this doesn't happen neither. If this happens, then this doesn't happen, and this doesn't happen, and the same for the last one. And what does it mean that we have mutually exclusive events? What does this mean when we have this type of composition? Or, for example, if I give you this, the probability of or B, A or B. If you know that A and B are mutually exclusive events, then this is simply the addition of the probabilities. Okay, why? Why is this true? Because of the following. I'm gonna write this in yellow. If you write down the if you write down the whole formula for the probability of the union of two events, that's gonna be this plus this plus this. Okay, and if you know that you are dealing with mutually exclusive events, if you know that A and B are mutually exclusive, what that means is that they cannot happen at the same time. If one happens, if A happens, then B doesn't happen, and vice versa. If B happens, then A doesn't happen. They cannot happen at the same time. That's the definition of this thing. So therefore, since they cannot happen at the same time, then this probability, the probability of both happening at the same time, is 0, and then you're just left with this. The probability of A or B equals basically just the sum of the probabilities when you know that you have mutually exclusive events. That's why I wrote this. That's why I wrote this. Okay, and it doesn't make any difference whether you have just two events or even more. For example, this. Even if you have more, the probability of A or B or C, if you know that A, B, and C are mutually exclusive, then this is equal to the sum of the probabilities, like this. And therefore, that's what I can do here. Since I know that this, and this are mutually exclusive, and they are separated by ORs, by this symbol, then all of this probability resolves into the following: the probability of going by bus and bus plus the probability of going by car and car on Monday and Tuesday plus the probability of going by bicycle and bicycle. Okay, and we know now, given our previous questions, we know how to solve this and this and this. I mean, we actually have we already have this one, which is it's this going by bicycle and bicycle. It's 0.09. So it's basically just a multiplication. And therefore, this probability of going by bus and bus will be 0.5 times 0.5. The probability of going by car and car, that's 0.2 times 0.2. And the probability of going by bicycle and bicycle is 0.3 times 0.3. And that's it. This addition, or this number, is actually my result for C. Okay, okay, that's this question, and it was a little tricky. Now D, I think this one is a little trickier. The probability that he goes to school by different methods of traveling in Monday and Tuesday. Uh, by different. No, this is actually Uh, no, this is actually quite simple. Let me erase this whole thing. Now, I will just give you the the brief sketch of on how to solve this one. I'm gonna do that in blue for D. The probability that he goes to school by different methods, Now, the difficulty with this, guys, is that if you attack it directly, it's gonna take you a lot. I mean, it has a lot of combinations. That's what I mean. You have 2 days, Monday, Tuesday, and since you have many ways to uh, to go to school, bus, car, and bicycle, you can have many different combinations. For example, I will just give you a sample: bus, car, bus, bus, bicycle, bicycle, bus, car, bus. Uh, I already counted that one. Okay, so you have many, right? And you're gonna be adding a lot of stuff and so on. This is not a wise method of attacking this problem. The direct method. This would be the direct method. What could be a better, wiser, more intelligent way to attacking this problem by calculating the probability of its complement. Let me label this event D. All of this stuff is D, that he goes to school by different methods. I'm calling that event D. What about D prime? If D is going by school by different methods, then D prime is going by the same method, right? By the same method, which we already calculated, as you can see here. Okay, that's it. So we already have whatever answer, which was this one, by the way. This is the previous answer for letter C. Whatever number this is, let's suppose, I don't know how much this number is. Let's suppose 0.5. Let's suppose. Then that's it. Then the probability of the prime is going to be 0.5, and therefore, automatically, the probability of D, which is the one that we're after, has to be 0.5, so that the addition of these two gives me 1. You see? That's it. That's it. It was a simple problem to solve if you think of answering it indirectly by making use of its complement, which is a very common technique in probability. Sometimes the the direct prob the the probability of the event itself that you're trying to get is quite complicated to get. It's much better sometimes to calculate the probability of its complement, which may be very easy, and then by making use of the known formula, if you know this, then you can know this. That's how you can solve this one. And the probability of going by train is 0, because the problem clearly states that it's either by bus, bicycle, or car. So this, I mean, this is 0. This is 0, and that's problem number 2. Problem number 3 and 4, I'm gonna bypass. They are extremely simple. I believe everybody got those right, or 99% of you got those right, so I'm not gonna waste time in there. And for this one, finding median. Okay, this is pretty much the same as the one that appears on type A. Although instead of in here it's multiplication, multiplying, and on type A was addition. But it follows the same scheme. It follows exactly the demonstration for B and for A are extremely similar, are extremely similar between both of them, between this one from type B, which is this, and the one from type A. So if you want to take a look at how this one is solved, take a look at type A on this problem. And that's it, guys. That does it. Thank you.